Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 4.3, ckBTC and Bitcoin integration, we're going to be talking about ICP's chain key cryptography and its direct integration with the Bitcoin network. So one of the key features that ICP is known for is the chain key cryptography, which is a unique feature that encompasses several cryptographic mechanisms that enable novel workflows and functionalities such as chain key tokens. A chain key token to some may be thought of as a wrapped token, but they are not wrapped tokens. They are twin tokens that are backed one-to-one with the original token, such as BTC, and they use chain key cryptography to transfer and use the original tokens on ICP with less fees and faster transfer speeds than using the token's native blockchain network. Currently, ICP supports an integration with the Bitcoin network and has the chain key Bitcoin token, or ckBTC, and ICP also supports other chain key tokens such as ckETH and ckUSDC. Throughout this documentation, you may notice the different capitalization of the term Bitcoin. The lowercase version of Bitcoin refers to the token BTC, while the uppercase version refers to the Bitcoin network itself. So let's talk about ICP's integration with the Bitcoin network. So the architecture of this integration is that canisters deployed on ICP are able to receive, hold, and send Bitcoin, utilizing transactions on the Bitcoin network and allowing each of the canisters to act as if they are users on the Bitcoin network. To enable this functionality, at the core of this integration is the chain key signatures that are based on threshold ECDSA. This is a protocol suite that includes several features that include key generation, periodic key resharing, computing pre-signatures, and XNet key resharing, as well as public key retrieval. At a high level, subnets that have ECDSA enabled are able to hold a threshold ECDSA master key, which is generated using ICP's key generation protocol. That master key can then be used to generate canister ECDSA keys. And it's important to note that an ECDSA private key only exists in a secret shared form during its lifetime, whether it is being generated, shared within a subnet, or shared from one subnet to another. We'll dive deeper into threshold ECDSA in a future tutorial, or you can take a deep dive on the technology overview page to learn more. But for this tutorial, the high-level view is all you're going to need at this time. At the protocol level, the Bitcoin integration and chain key ECDSA each expose an API on the IC management canister. Recall that the management canister isn't really a canister, but a facade that is used to enable functionality for management operations, such as starting or stopping a canister. The Bitcoin API is specific to the Bitcoin network, but the chain key ECDSA signature API can be used for other workflows, such as integration with other blockchains like Ethereum. In order for a canister to make a Bitcoin transaction, a request must be sent to a Bitcoin-enabled subnet. On that subnet, a Bitcoin canister is implemented as a typical NNS-managed canister that is accessible through that management canister's Bitcoin API. The Bitcoin canister can hold ICP's on-chain Bitcoin state, which includes the UTXO set, the most recent Bitcoin blocks, and the current outgoing transactions being sent to the Bitcoin network. Then when a canister submits those transactions to the Bitcoin management canister API, the transaction is queued to be submitted to the network. Then to send those transactions to the Bitcoin network, the ICP nodes use an adapter that connects the nodes of the Bitcoin subnet to the Bitcoin native network. And then in every subnet round, the Bitcoin adapter obtains the pending transactions and queues them to be submitted over to the Bitcoin native network asynchronously. So ckBTC is an on-chain ICP token that is backed one-to-one by Bitcoin, where one Bitcoin can always be redeemed for one ckBTC. All of the Bitcoin that is backing ckBTC is held within a smart contract on-chain on ICP. ckBTC does not use a third-party bridge, which makes it more secure than other pegged or wrapped tokens. When you compare BTC to ckBTC, ckBTC is able to have much faster transfers at a much cheaper rate. A ckBTC transfer is finalized within seconds and costs 0.00000001 ckBTC, which is approximately 2 orders of magnitude lower than the traditional Bitcoin miner fees. The ckBTC functionality is provided through the ckBTC miner and ckBTC ledger canisters. There are several different use cases for Bitcoin on ICP. Just a few of them include that ckBTC token, decentralization swaps, Bitcoin smart contracts, or trading Bitcoin. So in this tutorial, we're going to be deploying a Bitcoin dapp in our local replica or our local developer environment. This is going to be a simple example application that uses a local instance of the Bitcoin network and simulates Bitcoin transactions using it. This example is used to showcase ICP's Bitcoin integration, and it will not use ckBTC. Developing with ckBTC uses a different workflow, which will be showcased in a future variation of the developer journey series that will be focused entirely on the chain fusion integrations that ICP has, including the Bitcoin integration and the Ethereum or EVM RPC integration. So as a prerequisite, please be sure to have your developer environment set up according to the instructions in module 0.3, developer environment setup. And then we're going to begin by setting up a local Bitcoin network. This is because to develop a Bitcoin app locally, we're going to need a local instance of the Bitcoin network to be running that we can interact with. This is useful because the local network allows us to mine blocks quickly and facilitates testing without having to rely on the Bitcoin testnet or Bitcoin mainnet. So to get started, we're going to first download the Bitcoin core. For Mac users like myself, it's recommended to use the .tar.gz file. So we're just going to open this up and download our Bitcoin core. It looks like the latest version is 27. So we're going to go ahead and download that. And we can see that that got downloaded. And so then we are just going to move that from our downloads, and that's the Bitcoin core, and we're just going to move it to our current working directory. So now we can see I've got that Bitcoin package, and it looks like I actually have the zip one that got downloaded automatically. So let's just go ahead and make sure we get that correct tar.gz one instead. Let's see, did that give it to me? Yes, okay. So let's just okay, so now we've got that tar one instead. And so now we are going to unzip it with tar, and we're going to use the XFZ flags and then the name of that package. And it looks like it didn't like my Z flag. So let's just use X and F. Now we're going to navigate into that new Bitcoin, and it looks like the latest version is 27. And while we are in this, we're going to create a new directory called data. And then we're going to open up the bitcoin.conf file. So I'm just going to open it up here in VI. And it looks like there's a lot of stuff in here. So we're going to actually close that. And I'm going to open it up in VS Code so we can take a better look at it. So I'm just going to open my developer journey, and this Bitcoin folder, and then open up this bitcoin.conf. And let's see, we're going to insert this at the beginning of the file. So I'm just going to go ahead and copy that entire section, and we'll get this fixed a little bit. And so after these first couple of lines, we're going to go ahead and insert this, and then we're going to use Command S to save that. And so what this does is it enables regtest, which is required for local private Bitcoin network instances. Regtest is short for regression testing mode. It's going to set some test credentials that are going to be used by the local instance for authentication. And so then we are ready to start our local Bitcoin instance. And so we are going to use the /bin/Bitcoin D. Then we're going to give it the conf flag, and we're going to have that equal the current working directory with pwd. And then we want that conf file to be bitcoin.conf. And then we want data_dir or data directory. We want that flag to equal the current working directory /data. And then we want to pass the flag port, and we want 18444. So I'll press enter, and we're going to see that Mac is going to give us this error saying that it cannot be opened because the developer cannot be verified. And if we go into the little help menu with the question mark and then open privacy and security settings for me, we can scroll down and hit cancel. And then let's try and run that again. And let's see, privacy and security. And here that we scroll down, we can see Bitcoin D was blocked because it's not from an identified developer. We're going to allow that anyways. So then we'll close all of this. And then go ahead and now when you go to run it, it'll ask you if you are sure you want to open it. And we do want to open it. And it's going to ask if we want the application to accept incoming network connections. And for this, we're going to click deny since we don't want it to accept outside network connections. We're just looking to use the regtest local network. So we're going to hit deny. And we can see that it took up the entirety of our terminal output. And we can see that it was able to spin up a local Bitcoin instance with a local network. So now we are going to need to open a new terminal window. So I'm just going to open a new window, and we're going to keep that Bitcoin one running in the background. And I'm just going to open this up, and we'll keep a little output at the bottom. Well, actually we'll put them side by side here. That'll work. Okay, so next we are going to clone the basic Bitcoin example from the DFINITY examples repo. So I'm just going to copy this git clone and this cd command from the tutorial. And in my instance, I already had that examples repo already existing, so then it just navigated me into that existing basic Bitcoin one. So now we're going to start a local instance of DFX with DFX start clean background. And we're going to see that our DFX local replica is going to automatically connect to the local Bitcoin adapter. And we're going to see that the canister Bitcoin integration gets installed and some other output about the local Bitcoin integration running. And so the output of this is also going to take up the terminal window. So now we have the Bitcoin terminal and the Bitcoin integration terminal. So we're just going to make both of these a little bit smaller so we can still have them to reference their output. And then we will open a new window and put that on the bottom here. And then we're going to want to get back into our examples, examples, Motoko, basic Bitcoin example subdirectory. And this project uses Git submodules. So we want to run the Git submodule update init recursive command to update the submodules. And if we are on Mac, like I am, we need to use Homebrew to install a couple different libraries. If you're on Linux or another operating system, you'll use whatever your local package manager is. But on Mac, we're going to use Homebrew and use brew install. We're going to install the package LLVM, the package bin Arian, and CMake. So we'll give those a few minutes, and once we have those installed, we are ready to deploy our example canister. So we're going to use dfx deploy. The canister is going to be called basic Bitcoin, and then we're going to pass an argument flag, and this is going to use this variant reg test since we want to develop locally on that reg test network that we set up in the bitcoin.com file. So I'm just going to copy and paste this over to my terminal, make sure that it gets formatted correctly. I'm going to hit enter, and we can see it's going to deploy the basic Bitcoin canister. So now that it is ready and it's been deployed, we can interact with it. And first we are going to generate a Bitcoin address. So in order to receive Bitcoin, we need that Bitcoin address. There are a couple different types of Bitcoin addresses, and most can be generated using an ECDSA public key. So in this basic Bitcoin canister, the code has an example that generates a P2PKH address using the ECDSA public key. So we're going to call that method of the canister with dfx canister call basic Bitcoin, and then get P2PKH address. And it looks like I made a typo. I hit W instead of 2, so mine failed. So we'll fix that typo. And now we can see that we've gotten a Bitcoin address. And alternatively, you can also use the Candid UI for this, and this Candid UI is available at the canister's Candid interface URL, which is highlighted in green in the terminal. And then now that we have a Bitcoin address, we can receive BTC on our local network. Bitcoin uses the proof of work consensus mechanism, which means that blocks on the network need to be mined in order to have BTC be minted, since BTC is rewarded to miners as compensation for mining those blocks. On the Bitcoin testnet and mainnet, you cannot control when blocks are mined, but since we have a local Bitcoin network running, we can manually mine blocks using the following command with our Bitcoin in our Bitcoin D directory. So I'm just going to first copy this piece of code, and then we are going to need to open another terminal window. And for this one, I'm just going to put it over in the top here so we can still see everything else we've got going on. And I'm just going to navigate back into that developer journey and then the Bitcoin 27. And then I'm going to paste that command that is going to generate address, or generate to address, number of blocks address. And so we'll see that I have to fill in these last 2 bits. So for example, we are going to just mine 1 block, and then we're going to go over here where we got our Bitcoin address, and we're going to paste that in. And it looks like we are running into that same error where we got stopped from running it because the developer was not verified. So we're just going to follow that same process of opening the privacy and security settings in Mac, scrolling down and hitting cancel, and then going over here, running our command again. And now if we go into privacy and security, we can see Bitcoin CLI was blocked. We're going to hit allow anyways, and then verify. And then we'll close these windows and run that command one more time. And now we'll have the option to hit open. And we can see that now we've gotten a hash of the block that was just mined. And then in the terminal window over here, that is showing the DFX start output. And so now over here, we can see in the Bitcoin D window that we've got here that's showing us the local Bitcoin logs, we can see that there is a new block. And we can see the height, it's the first block. We can see the date and the time. And then if we want to check the balance of our Bitcoin address now that we've mined that block, we can do DFX canister call, basic Bitcoin, and then the get balance method. I'm just going to copy and paste the BTC address portion at the end. And then, let's see. Oh, and silly me, I copy and pasted it, but we need to replace that address with our proper address. So we'll just go ahead and copy and paste that. And that should work now. And we can see that we have what appears to be 5 billion, but this equals 50 BTC. And so remember, this is local BTC. This is not valid on the testnet or the Bitcoin mainnet. It's not real BTC. It cannot be spent or used anywhere else. And so now we mined a single block and received a reward of 50 BTC. One prerequisite before you are able to send BTC to another address, though, is that an additional 100 blocks must be mined. This is known as the Coinbase maturity rule. So to mine an additional 100 blocks, we're going to copy and paste this command back into our terminal over here. And remember, this last portion here, we need to paste in our Bitcoin address. And we can see we get all of the hashes of all of those 100 blocks. And then we now have the ability to send BTC to another user. And so in this example, we're just going to use this dummy address. You can replace this address with any address that you'd like. And so we're just going to use this DFX canister call basic Bitcoin send, and then destination address is that dummy address, and then the amount in Satoshi. And so I'm just going to go ahead and copy and paste that command over here in the terminal. And we'll wait for that to process. So now we've sent this transaction and we've gotten the transaction hash, but now we need to mine a block so that the transaction that we just sent becomes part of the blockchain. Without mining a block after sending this transaction, the transaction will not be recorded on chain. So now we're going to go back to our terminal over here. And we are going to run the following command to go ahead and mine another block. And this one here, the address is already inputted, but we are going to just go ahead and use our Bitcoin address again. And then now we can use the DFX canister call command to check that the transaction was recorded. And so the address that we sent it to should now have a balance of 1 Bitcoin. So I'm just going to go ahead and copy and paste that command into the terminal. And now we can see that this address has some Bitcoin in it. Mine has more than the amount in the tutorial here, since I ran this transfer a couple of times to make sure that it was working properly. And so for me, this address now has 50 Bitcoin in it. So that'll wrap things up for today's tutorial. Please be sure to like and subscribe to the DFINITY YouTube channel if you like today's episode. If you have questions or feedback, please reach out on the Discord channel for the ICP developer journey, or reach out on the developer forum. There's also a thread on there for the developer journey feedback and questions. In the next episode, we'll be looking at the NNS and SNSs and talking about governance on ICP. Until then, take care.